This video is about even and odd functions. A function can be called an even function when this first statement is true, that f of negative x equals f of x. And there's a similar statement about odd functions where f of negative x equals negative f of x. One way to understand what these statements mean is to look at them graphically. So let's start by looking at even functions graphically. We'll use this graph for an example of an even function. So this statement, f of negative x equals f of positive x, I want to think about this in terms of a function representing some input value and then calculating an output value. So the input would be whatever I have in place of the x, and the output would be represented by this expression f of x. So the input right here for the x, and then this whole expression would be the output. So this statement is saying, if you look at the value of the function when you input some variable x, the value of the function is exactly the same if you were to put in the opposite value in place of x. And on a graph, that would mean that they have the same y coordinate. So like we could take, for example, any point on the graph where we've got a positive x, and then the function will have the same value for a negative value of x. So for an example, if I look at the value of the function when x equals positive 1, looks like we are just a little bit above the x-axis. The function will have the same value when x is negative 1. We should still be just a little bit above the x-axis. Now let's take a look at a few more examples where we can find these points of f of x equaling f of negative x. Here's the value of the function when x is about 1.5. So when x is negative 1.5, we're going to see the function have that same value right there. Here's another one, and the function has the same value at negative x. So whatever the value of the function is at the positive x, it has the same value at negative x. We start to see that when f of x equals f of negative x, the graph shows this symmetry. It is symmetric about the vertical axis. So this statement, if it's true for every single point, in addition to these ones that I've selected here, so all even functions will have this symmetry about the vertical axis. And this is a result of this statement being true, that f of negative x equals f of x. Now let's look at odd functions. Odd functions will satisfy this requirement that f of negative x equals negative f of x. So now if we look at putting in the opposite x value, we will see that the entire value of the function becomes opposite. So let's look at some examples with this graph to see what that means. For the first point, let's look at the value of the function when x equals 1/2, and it is just approximately equal to 3. And so an odd function would mean that if we look at the value of the function at negative 1/2, it's going to equal about negative 3. Before, with an even function, we saw that it equaled exactly 3, the same value, but an odd function, it will be the opposite. So the graph of our function will go through this point down in quadrant 3. Let's look at a few more examples. This point is the value of the function when x equals 0.2, and here's the function when x equals negative 0.2. Here's another point, x is about 0.8, and there's f of x. And so an odd function will also have the point negative x and negative f of x. And one more point, when x equals 1, f of x is a negative 2. And when we look at the opposite x value, negative 1, we'll get the opposite function value, positive 2. And one more point for an example. And if we do this for all the points on the graph, we'll see that the graphs of odd functions have this kind of a symmetry. It's not exactly symmetric about the vertical axis, and you might try to see some kinds of ways that this is symmetric, but odd functions have symmetry about the origin, is what this is called. And one way to think about symmetry about the origin is to think about if you were to take the graph of this function, and if you picked it up and rotated it 180 degrees, it would look exactly the same as how it looks right now. So it's symmetric. You could sort of think diagonally. There are some things in quadrant 1 that are similar to quadrant 3, and that there's similarities between quadrant 2 and 4. And symmetric about the origin is this idea that if we were to rotate this graph by 180 degrees, it would look exactly the same. And this is a result of this statement being true, that if you look at how does the function compare with positive values compared to inputting negative values, you'll see that putting in negative values gives the opposite function value, and that's an odd function. So if you're able to look at the graph of the function, you'll see even functions have this symmetry about the vertical axis, like these four examples. And odd functions will have symmetry about the origin, like these four examples. If you're not able to look at the graph of a function, but you need to tell algebraically whether it's even or odd or neither, then you could use these steps. Let's take this function for an example. Remember, this is how we define even and odd functions. Even functions, f of negative x equals f of x. Odd functions, when we put in negative x, we get the opposite of the function, negative f of x. So given this function algebraically, if we don't have a way to look at the graph of this function, then what we can do is evaluate this function for f of negative x. So in each of our variables in this expression, we're going to be putting in a negative x, and then we're going to simplify this expression. Where we have these terms of negative x with an even exponent, that's going to give us back a positive x squared result. So that's the kind of simplifying we can do here. Same with the denominator, a negative x to the fourth power equals x to the fourth. And possibly it's because of those even exponents that we call these even functions, that there's something about when you have a negative x in place of the variable, when the exponent is even, that becomes positive. So inputting the negative x looks the same as putting in positive x. And that happens with even exponents a lot. So what we have here after simplifying is an exact match to the original function. So there was the given function, f of x, and when we put in a negative x, we see that it equals the exact same expression. So we've got an even function. Let's look at another example. F of x equals 4x to the fifth minus x. So let's take the same strategy and evaluate this function and really simplify when we have a negative x in place of the variable x. Where we have negative x with an odd exponent, that will end up having the same sign as the base originally. So this will become 4 times negative x to the fifth, or a negative 4x to the fifth. And this will become minus negative x, or plus x. So we have the function evaluated and simplified at negative x, and we can see that we do not have a match with the original function, which we had in the last example, which was an even function, but now we see not a match. So now we can check to see if we have an odd function. We want to compare this result of f of negative x to see if it will match the opposite of the original function f of x. So I'm going to take this entire expression from above and simplify the opposite of that expression. And I can see that I will match up with the negative 4x to the fifth plus x. So there's our match between f of negative x with negative f of x. So that means we've got an odd function up here. And now let's do one last example. Here's our given function f of x. If we evaluate this function at negative x, this first term simplifies to become a positive 3x squared. That middle term is negative x, and then minus 4. So we can see that we do not have a match with the original function, so it's not an even function. Let's check to see if it could be an odd function and look at the opposite of this original function. And simplifying by finding the opposite of each of these individual terms, we can see that we don't have a match here either. So that means it's not odd. So it's not even, it's not odd, it's one of these neither even nor odd functions.